Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Alright guys, so let's look at some examples on integration by what? By parts. Okay? In our previous class, we were able to derive the formula for calculating or solving any problem regarding what? Integration by what? By parts. And we arrived at this formula, right? That says what? Integral of what? U dv equals uv minus what? V integral of what? V d what? Du. Are you there, somebody? Now, listen, pay attention, please. Before you start integrating, please pay attention. There are 4 steps you must have to take note of. 4 good steps. Are you following? The first is that you have to identify which of the function will represent your what? Your u. Like, let's say, for example, if we are given this integral of, let's say, x sine what? Sine x, or in what? Dx. And we have to integrate this. You know, we have other forms of integration, right? I gave us. Who can remind me of other forms that looks like this? Other forms of integration that looks like this. Not power rule. What if I'm not getting your book? What are other forms? Divine. Oh yeah. Other forms I taught you guys. Form, like I give you guys first the UAB over UAB, which is same as what? Integral of what? 1 over u d what? Du. You know also. I also give you guys integral of what? U d what? Du. Isn't it? Which is same as f of what? F of x abi dot what? F prime of what? Of x abi. You know what I give you guys? These are the forms. This is of this form. This is of this form. If you look at this form looks exactly like this, right? Isn't it also? This simply means product now. U times. But there are some questions that appears like this that I can't use this form to solve. Like, for example, now, if I'm to apply this form, even though we say let u equals to what? Equals to what? X. Are you following now? Your du dx is not equal to sine x. The only time I can use this form is when you make your x as your what? As your u. And when you differentiate that u, you must have what? The second variable. It's not this. Where in class? Ella? Are you serious? Where in class? But you know what I'm saying, Abi? Are you sure? Okay. Give me a good example of it. Let's see. Let me show you something. Listen. If I have integral of sine x dot what? Cos x, all in what? Dx. Listen. The form here is what? We say form of what? U d what? Du abi. If I have this, I cannot use by parts to solve this. Do you know what I can by parts? We have 2 different words, elementary word functions. You know, okay, let me not go into this now. For this now, I have to say let what here? Let u equals to what? Sine x. Abi? Then we say du d what? Dx will give us what? Cos x. Abi? That means what? My du equals to what? Cos x d what? Cos what? Cos x d what? Dx. What do you notice here? We say let our u equals to what? Sine x. When you then differentiate what? U with respect to what? To x, we have what? Cos x. I see it this here. But for this kind of question, these two they are still products, right? Isn't it so? If my u equals to x, when you differentiate u, I cannot have sine x. That means I cannot use this form to solve again. I have to use what to solve? By parts. Is the gist clear? Now watch now, listen. Integral of u dv, formula says, is equals to what? uv minus what? V integral of what? V du. Before you start integrating any function by parts, the first is to identify your what? Your u. Identify your u. When you find your u, find your what? Your du. When you know your u, you can find du. What's the du? Yeah, I'm coming to the v. Identify your u first. From your u, you can get your what? The u. Identify your what? The V. Integrate it to find what? To find what? V. Do you get the gist here? From U, we can get the U. From the V, I can get what? V. Oh, yeah, right. Steps, right. Put it down first. Steps. Steps. Using integration by parts. Steps used in integration by what? By parts. Number one, identify U and the V. Number one, identify U and what? And what? The V. Number two, differentiate U to get what? The U. Differentiate U to get the U. Differentiate. Differentiate what? U to get what? The U. Number three, integrate the V to get V. Number four, apply the formula. Apply what? The formula. Number one, identify U and the V. Number two, differentiate U to get what? The U. Number three, integrate the V to get what? V. Number four is what? Apply. Apply what? The formula. And what's the formula? Integral of what? U dv equals uv minus integral of what? V du. Don't forget. Are you following somebody? Okay, let's solve a problem with this, right? Are you following? We have seen from here, if I have integral of sine s cos s ds, are you getting it now? Will I use by parts here? No. Are you getting it? Hello? Are you following? Are you following? Tell me one or two things you understand here. If you are following. Formula is this, Abi. Yeah, talk about the formula for me. Talk about it. Yes. To solve, yes. Uh-huh. Uh-huh. To get V. Uh-huh. To get V. Good. Now, if I have two functions, thank you. If I have, let's say for example, now we all got it right. If I have a function, listen, let's say I have this integral of x sine what? Sine x dot what? Somebody, the x. Listen, if I have this to integrate, how do we know which of these is our x? Which one is our u and what? The v. Thank you. Yeah, my class. Clap yourself. Clap yourself. Clap yourself. That is strange to some of them. No one you understand. Listen, please. If we are given this to solve, are you getting it now? Never you use this as comparison. From here, we know our x is what? U and v. What's our sine s dx? Dv. Is it not? But don't use this. There's what we call priority order for u. How to identify u, how to choose your u. If you can be able to know which of these functions is your u, then the here becomes your what? Dv. You get this here? The first thing is that we have to choose your u and what? Dv. But your emphasis should be on what first? On your u. If you can get your u, then the other one becomes your what? Your dv. Now subheading right. Choosing u and dv. How to choose u or choosing u and dv. Choosing u and dv. Choosing what? U and what? Dv. Please, you have to note. Please pay attention, please. I'm not flowing in this class. Ella, you're distracting me. What's happening there? You have to take note that the hardest part, listen, you have to be careful. If you can be able to identify your U and your DV, then the rest becomes what? Becomes a story. Becomes easy to solve. Either the hardest part is always which of the function will represent what? Our U and what? And DV. Please write. There's a priority order for choosing U, right? The priority order for choosing what? U. Priority order for choosing U. We have what we call priority order order for what? You see? What is that? Oh, yeah, listen, please. Listen. We have a priority order for what? For you. Are you getting it now? Hello. I use an abbreviation called what? L what? It's called what? LIATE, right? To determine what? The order for choosing what? You. Are you following somebody? The order for choosing you is what? Somebody. What do you pronounce that? LIATE. LIATE. Huh? LIATE, right? LIATE. What we know here is that the word L represents what? Logarithm functions. Abi? Logarithm what? Functions. E.g. we have what? Our link what? X. We have what again? Log X, right? Second word is what? I. I represent what? The next one is I, right? I represent what? Inverse trig. Trigonometry what? Function. Which is what? Like your sine inverse, Abi, of X. Your cos inverse of what? Cos inverse of what? Of X. Your tan inverse of what? X. etc. Right? Are you there, somebody? What the next one? A. A represents what? Algebraic. Thank you. Algebraic what? Functions, right? Give me an example of it. Your X, comma, X squared, X cubed, etc. Right? Are you there? Then the T represents what? Your trigonometry. Trigonometry, right? Functions. Okay. Here we have what? You can tell me. Sine, like sine X, cos X, tan X, sec X, blah blah blah, right? Okay, what again? E represents what? Exponential functions, right? EG is what? EX, Abi? What again? AX, etc. Either. This is the priority order for choosing what? For choosing your U. For choosing your what? Your U. Logarithm function. Inverse what? Trig function. Algebraic function. Trigonometry what? Function. Exponential what? Function. So if we are given this, for instance, we have to integrate this. Either. The first thing you have to choose is your what? Your U. So which of these will represent our U based on this order? X, Abi? X, right? Why is it X? Because in the priority order of what? Of U, our algebraic function come before what? The trigonometry one function. We have X first before what? Having sign. So that means here, our U is equal to what? X. Is it making sense? Are you getting the gist here? What if I have exponential X, sine X? What will be your U? Sine X. Why is it sine X? Because exponential is what? Is the last. So in your priority order for choosing U, your trig comes first, Abi? And trig is order where we have sine, cos, and tan. Is it making sense here? But let's solve for this first. So if this is my X, this is my U rather, this becomes what? My dv. Are you following? You know, say the first thing is to choose your U and what? Dv. We have chosen U, right? Are you following? When you choose U, can we get the U from U? How do we get the U? I will differentiate it, right? When differentiate the what you have here, the U, the what? The X is equal to what? 1. Can we cross multiply this? That means my du is equal to what? What's 1 times the X? The X. Is it making sense? Now, I've gotten my du as what? The X. I've gotten my U, right? Is it not? What's that U? X. What's that the U? The X. Let's find out now. dv. What will be our dv here? Sin X. Is it not sin X? Good. Sin X. The first step, choose your U and what? Somebody. And your dv. We have chosen X as what? U. It means sin X becomes what? Our dv. Now, if sin X is our dv, what do we do here? Can we solve for v here? You know, so you know, say when we choose your U, differentiate U to get what? The U. Then integrate the V to get what? Your V. So if I'm to integrate the V, what do you have? By the time we integrate the V and what? Sin X, what do you have? V then becomes what? minus cos what? Cos x. Are you following? Is it making sense here? How do we achieve this? We integrated what? Both sides now. Integral of what? dv is what is v. Integral of sine x is what? Minus cos x from what we have here. Is it making sense? Now listen. Now we have gotten our what? U and b. We have our what again? Our du. What again do we have? We have our what again? Our dv, right? What's that dv here? Sine x, is it not? Is it not? dv is what now? Sine x. What's that v? Minus cos x. Then recall that integration by part formula says what? Integral of what? U dv equals to what? uv minus integral of what? v d what du. So that means what? Here becomes, what's that uv? What's that u again? Let's go. X, abi? What's that v? Minus, that's times minus cos what? X. Minus again, abi? Integral of what? What's that v? Minus cos what? X. Are you following somebody? Du is what? This is the u. Hope you are aware. Du is what? Dx. Dot what? Somebody. Dot dx. I can actually evaluate this here, right? Amount is what? Is plus. So we have what here? Minus x cos x plus. Is it not? Plus integral of what? Cos x dx. Are you following? Now, we can integrate cos x, abi? The right to integrate cos x is what? Dx now. When integrate cos x, what do you have? Eh? Who says minus sine x? If you integrate cos x, what do you have? Sine x now. So what do you have now? Let's go. There we have minus x cos x plus what? Sine x plus what? C. Final what? Answer. Are you getting the gist here? Please don't forget. When you integrate cos x is what? Sine x. When you differentiate sine x is what? Cos x. The reverse is still sine x. But when you integrate sine is what? Minus. Don't forget. Are you there, somebody? Okay, for this one, example 2. Listen, please. For this example, we have to evaluate this. Integral of x exponential what? X dx, right? Are you following now? What the first step here? You can tell me the first step. We identify your u, abi, and your d and your dv. What's our u here? X. Is it not so? In fact, whenever you see exponential, know that is your dv. Because in the priority order for what? For u, that's the last part, abi. Hope you are aware. That means our u is what? U is what? The x. So from here I can differentiate for u, right? The respect to x. What do you have here? The u, the what? The x equals to what? Equals to what? 1, right? That means that our du then is equals to what? The x. Because by the time we cross multiply, we have what? We have the s. Is it not so? Okay. Now we have gotten our u and what? And our du. Let's get to our dv. What's our dv here? Dv is what? Exponential what? X. Is it not so? So for me to get v, we have to integrate this, right? If we should integrate exponential x, what do we have? Exponential what? X. That means that integral of both sides, integral of the v is equals to integral of what? Exponential x. And that will give us v equals to what? Exponential x. Are you there? When you differentiate exponential x, it's still what? Exponential x. When you integrate exponential x, it's still what? Exponential what? X. It does not change. Is it not so? So now we have our dv as this, v as this, right? We have gotten our u, our du, we have our dv, and we have what? Our v. Then the formula for integration by parts says what? Says what? Integral of what? U dv equals to what? uv minus integral of what? V du. Let's put the value here. Let's go. What do you have? What's our u? Our u is x, right? X multiplied by what? What's our v? V is what? Exponential x, right? Minus integral of what? What's our v again? Exponential x. But what's our du? Our du is what? Dx. Are you there, somebody? So that will give us what? X exponential what? S minus Integral of exponential x dx is what? Exponential what? X. Then plus what? Plus c. Between these two terms, what's common? Exponential x, right? Is common. In bracket, what do you have here? X minus what? 1 plus what? Plus c. All equals to what? Integral of what? Of u dv. Final answer to this. Let's see example 3. We are given this, evaluate this. In this case, we have x squared, yeah? Right there. And we have multiplied with what? Exponential x all the x. Okay, in the priority order for u, what will be our u here? X squared, right? Okay. Our u is x squared. So by the time we differentiate this, the u, the what? The x. What they have is 2x. So that means our the u gives us what? 2x what? The x. Are you following? So the v becomes what? What is that the v? Exponential x, right? To find v, I have to integrate. And now give us v equals to what? Exponential x. Are you aware? Huh? Are you aware? Okay. So let's put the formula. Recall that the formula says that integral of what? U dv equals to what? uv minus integral of v du. Are you there? Integral of v du. Okay? So that means that our integral of u dv becomes, what's our u? Let's go, what's our u? Yes, x squared, thank you. Our u is x squared, Dot. What's our v? Exponential x, right? Minus integral of what? Let's go. Exponential what? Our v, right? Exponential x, dot what? 2x, the what? The x. So this will give us what? Integral of what? U dv equals to what? X squared exponential what? X minus x integral of what? 2x exponential what? X dot what? The x. Right? Right? If you look at this, I'm still having 2x and what here? Exponential what? X. It simply means I have to further what again? Integrate by what? By parts. There is no, yes. I will say integrate by parts. Because if I have x exponential x, it's just like this now. You know what I'm saying here? It's just like this. So if I have 2x, even 2x is also same as this. You know, the first example we solve, I think that should be integral of x exponential x, The first example we solve. It's similar with this now. The difference is just what? Just these two here. Do you get the juice here? But what we have to do here is this. I have to bring out these two here out. Then integrate what? Only x exponential what? X. Is it making sense? Is it making sense? Okay. So that means here becomes integral of what? U dv equals to what? X squared exponential what? X. Minus 2 integral of what? X exponential what? X dot what? The x. Please check for me in your previous note. The first example we solve, I guess is this. Right? What is the answer to that? Recall from the first example that integral of what? Of x exponential x is equals to what? Exponential what? X, minus what? Okay, x minus 1, right? Plus what? C. Are you aware? If you take back, the first example we saw is practically this. So what we do is to put this into what? To replace this, Abi. Are you following somebody? Our answer ended here. Then recall that from the first example we gave, that this expression is same as this. Even if you want to repeat the same process again, by integrating this by parts, you will still get this again, right? Can I continue? So it means that by the time we substitute the value, therefore it means that u, integral of what u do what? The v is equals to what? X squared exponential what? X minus 2 in brackets. Is it not? What do you have here for this? The whole of this is what? Sorry, this is what? Is this, right? Let's go. Exponential x. This is same as, let me just say, let me use the first one. This is same as what? X exponential x, abi, minus what? Exponential x plus what? C. If I should expand this, I will have this, right? Let me just put this direct. So what do you have here? X exponential x minus what? Exponential x. Okay. Plus what? Somebody. Plus C. And that will give us what? Integral of what? U dv is equals to what? S squared exponential x. Can I expand this? That will give us what? Minus 2x exponential x minus plus, thank you, 2 exponential what? X plus what? Plus C. Are they like terms here? What are like terms? No. It's just only exponential x. There's no x here, right? So that will give us what? Exponential x, right? In bracket, what do you have here? S squared minus what? 2x plus C. Then plus what? C. Do you get the gist? Alright, the next example, example 4, integral of x squared exponential 3x dx. In the periodic order for u, what's our u? X squared, right? Isn't that so? So our u is equals to what? X squared. So that means our du do what? Dx will give us what? 2s, right? Is it not? If du dx is 2s, what is our du? Is 2x dot what? Dx. We have gotten our u, we have our du. Let's find out our dv. What's our dv here? Our dv is what? Exponential what? 3x. Are you getting the gist here? To integrate this, integral of dv will give us v, right? That will give us what? Exponential 3x divided by 3. There's a rule that gave us, I don't know if you can remember, that if we integrate exponential kx, that will give us exponential kx over what? K plus what? Somebody? Plus C. Is it not? So the same thing we do. If I'm to integrate this, that will give us exponential 3x over what? 3. Our K is what here? 3. Are you getting the gist? From this general expression here. Is it clear? It's just the same thing. 3s is like saying ks. So eks over what? K plus C. You get the gist? Okay. Now recall, now we have our dv, we have our v. Recall that integration by part says what? Integral of what? U dv equals to what? uv minus integral of v d what? Du. Let's put the value of our u, dv, v and what? And du. Into the formula we have. Our formula says, let's go, integral of u dv is equals to what? Let's put the value. What's our u? Our u is what? S squared, dot. Our v is what? Exponential what? 3s over what? Over 3, right? Hope you're aware. Okay, let me put this, I will not be confused, over 3. Alright, minus integral of what? V is what? The same exponential what? 3s over 3, dot what? 2x d what? Dx. So this will give us what? S squared exponential 3s all divided by 3, right? Minus, I can bring out my fraction. What's the fraction here? No, 1, yes, 2 over 3, thank you. 2 over 3, integral of what? What do you have remaining? Exponential what? X, thank you. X exponential what? Dx dot what? Dx. The constant value here is what? 2 over 3. We'll bring it out. If this is out, that means we are left with what? X exponential what? 3x dx. Are you following the gist here? Okay. This is same as what? Integral of what? U dv. We can call this our I1. You get? Then we now say let what? I2 be equals to what? Be equals to integral of what? Of x exponential what? 3x. In simply means I will need to further integrate again by parts. By making this my u, right? What's our u here? X. What's our du? Is the x, right? What's our dv? Exponential what? 3x. What's our v? Our v will still be what? Exponential what? 3x divided by what? 3. Which one? Which x? This one? U. U is x now. And exponential is your dv now. Your algebraic function come first now. Algebra come first before exponential. Okay, is it different answer? Let me see. But you get the gist. In our LIATE, LIATE. Huh? E. This one comes last. Algebraic is here. Algebraic is what? Is x now. So my u is what? Is x. No. This way. Priority order is from here. Yes, we first. If there was log will be first. Okay. So let's look at what we have here. It simply means that our I2, right, will then be what? So I2 be what? Do you know why we say it's I2? Why we say it's I2? We are solving for this. Now what happened in that example I gave us? Yeah, you go back to you get it. I2, yeah? More than once. Okay, let's see. Here we have UV minus what? Integral of what? V the what? The U, right? So our I2 becomes what? Let's go. What's the I2? What do you have? What's that U? U is x. What's that V? 3x over what? 3, right? Minus integral of what? What's that V? What's that what? 3x. Dot, what's that du? Over 3, thank you. Dot what? What's that du? Dx. Okay. Dx. What do you notice here? The more you further integrate, the more the power of x will reduce. Like here we have here dx. 1 dx. Do you get the gist? So let's go. What we do, we bring out this, right? Now give us our I2 equals to what? X exponential what? 3x over what? 3 minus 1 over 3, right? Integral of what? Exponential what? 3x dot what? Dx. I can integrate it, right? So that will give us our I2 equals to what? X exponential what? 3x over what? 3 minus 1 over 3 times. When you integrate, what do you have here? Integrate exponential 3x. What do you have? It's exponential 3x now over what? Over 3 plus what? Plus CRB. But I'm not done with this. Hope you are aware. We're only solving for what here? For this I2, which is this. Is it not so? Hope you are aware. Huh? Okay, I think I will have called this equation what? 1. Right? Equation 1 is this. Let's solve. Let's go. So what's the I2 here? What's the I2? X exponential what? 3x over what? 3, right? Minus what? 1 over what? Okay, exponential what? 3x over what? 9. Plus what? Plus c. Do you get the gist? I will now put this. Let's call this equation what here? 2, Abi. We say put what? Equation what? 2 into what? Equation what? 1. Equation 1 is this now. We made this to be what? Our I2, Abi. So I'm putting back my I2 back to this original what function. Is it clear now? And that will give us what? Let's go. Let's go. What do you have here? Equation 1 says what? Let's repeat equation 1. It says what? I1, right? Equals to what? S squared. Exponential what? 3s over what? 3 minus 2 over what? 3 integral of what? X exponential what? 3s the what? The s. So let's put the value back here. What do you have? Our I2. I1 and that then becomes what? X squared exponential what? 3x over what? 3 minus 2 over, sorry, yes, minus 2 over what? 3 in bracket. Is it not so? What is the value of this? What do we solve as this? Is this, Abi? Give me the value there. X exponential 3x over what? 3, minus exponential what? 3x over what? 9. Plus what? Plus c, right? So let's evaluate further. This will give us what? I1 equals to what? S squared exponential what? 3x over what? 3. Okay. Minus, can we expand this? Can we expand this? Minus 2x exponential what? 3x over what? 9. Are you aware? Can we multiply this out again? What will it be? Plus 2 exponential what? 3x over what? 27. Are there like terms? What are like terms? Over 3, Abi. This we factor out. So that will remain what? Can I play the middle part? Okay. So this will give us what? Our plus C. Our I1 then becomes what? Let's go. X exponential 3x over what? 3 is common, right? So what's many here? X squared. Minus what? 2x over what? 3. Plus what? Plus 2 over what? 9. Right? Plus what? Somebody? Plus C. Is that your answer? Okay. Alright, so example. Look at this example we have here. We have to integrate integral of x squared in x dx. Right? Now, before we integrate this, we have to choose. We have steps to integrate by parts. Is it not? So we have to choose between x squared and the x. Which one will represent our u and the v? Right? Okay. But in the priority order I gave us for choosing u from the beginning, we have our LIATE, right? Is it not so? L represents what? Logarithm, which is your ln x or your log x. I represents what? Your inverse what? Your trig, inverse trig, right? Like your inverse of sine, inverse of cos. A represents what? Algebraic what? Functions. Y t represents what? Your trigonometric functions. It represents what? Exponential function. This is the priority order for choosing what? U, right? Okay, for this, it means that from this order, logarithm is the first. So that means my u is what? Ln x. Don't be tempted to u because integrating by power formula says what? Integral of what? Of u dv equals to what? uv minus integral of what? V what? Du. Because we have this as our formula does not mean that your x square is your u all the time. No. There is a priority order for choosing u. For choosing u, logarithm is the first. Is it not so? So that means my u is what? Ln what? Ln x. Is it not so? Followed by what? What's that the v? What's that the v? S squared, right? Okay. So the first thing is to choose u. U is equals to what? Ln what? X. U equals to ln x. In the differentiation table, I told us that when you differentiate ln x, what do you have? What do you have? 1 over x, right? So by the time we differentiate du with respect to what? The x, we have 1 over what? X. Right? So what we do to find du? We cross multiply. That means our du is simply 1 over x dot what? The x. Or we can say the x over what? X, right? Is it not? Don't come and start saying x cancel x. You know, the answer is what? D. And do not say that. I do not teach you that. Even the D will take notes. Don't divide x by x to get d. Are you following somebody? This is mathematical what? Error. Either it's not possible. Okay, now we have gotten our du. What's the u? The x over x. Now the next is to find what? The v. What's that the v from here? What's that the v? What's our dv? S squared. Right? Dv is what? S squared. So what we do is to find v, right? By integrating both sides. Are you following? So we have our v to be what? If we integrate s squared, what do you have? It's s cubed over what? 3. Are you aware? Are you aware? Now we have gotten our u. We have our du. We have our dv. And we have what? V. Let's put the value of each of these into the formula we have. Into our formula. Recall Now the formula says what? Integral of what? U dv is equals to what? uv minus integral of what? V the what? The u. So that implies that, let's call this I1, right? Are you there, somebody? What's that I1? What's that u? U is what? Ln f dot. What's that v? S cubed over what? 3. Are you following, somebody? Minus integral of what? What's that v? V is s cubed over 3 dot. What's that du? What's that du? Or we say the x over s, right? The x over what? Over what? X. So this is same as our I1 equals what? Ln x. Okay, let's multiply these two. What do you have here? That will give us s cubed ln s, right? Over what? 3 minus. One of these s we cancel what here? One of these s, right? Remaining what here? Integral of what? S squared over what? 3 ds. Is that not? Okay. So that will give us our I1 or I equals to what? S cubed ln x over 3 minus. Can we bring that 1 over 3 out? We have 1 over 3 integral of what? S squared what? Dx. Now we can integrate what here? S squared, right? With respect to what? To x. That will give us what? Our I1 equals to what? S cubed ln x divided by what? 3 minus 1 over 3 dot. Integration of s squared is what? S cubed over what? 3 plus what? C. So that means our I1 becomes s cubed ln x over 3 minus s cubed over what? 9 plus what? C. Between these two, what is common? So we have I1 is what? S cubed over 3 is common. In bracket, what's going here? Ln x minus what? If 1 over what? Yeah? 3. Plus what? Somebody. C. If s cubed over 3 is common, that means we have what here? Remaining here is what? Ln x minus what? 1 over 3. Do you get the G? Because 1 times s cubed is still s cubed. 3 times 3 is what? It's 9 plus C. Final answer to this is this. Alright, let's look at this example here we have here. Integral of what? Exponential 3s sine x ds, right? Huh? Okay, so what's our u here? In the priority order for u is what? Sine x. So let what? U equals to what? Sine x, right? Is it not so? So by the time we differentiate this, the u dx will give us what? Give us what? Cos x, right? And that will give us our du equals to what? Cos what? Cos x what? Dx. Now we have our u, we have our du. Let's find the v. What's our dv? Exponential what? 3s. Is it not so? Exponential 3s. By the time we integrate this, what do you have? V, right? V equals exponential what? 3s over 3. You are aware of that, right? Now we have gotten all the terms we need, right? We have our dv, we have our v. Then recall that the formula for integration by part says what? Integral of u dv, right? Equals to what? uv minus integral of what? d du. What's our u here? Let's solve. Let's call this I, right? Are you there? Let's call this what? I. So our I, in fact, this is still our I. Hope you are aware. If I eat this my I1, this is still what? My I1. Because I'm solving this with the formula. Are you getting the gist here? So let's go. So let's go. We have I equals what? Okay, what's our u be here? Our u is what? Sine s, Abi. Our sine x dot, what's our v? Exponential what? 3s over what? 3. The rule says minus, right? Integral of what? Our v is what? Exponential 3s over what? 3 dot, what's our du? Thank you. Cos x. Cos x what? Dx. Are you following somebody? So this will give us what? I equals to what? Sine x exponential 3x over what? 3, right? Minus integral of what? Sorry. Yeah, we're going to have 1 over 3, right? Integral. Here we have exponential 3x over 3. So I'll bring out what? 1 over 3 outside the integral sign. Okay. Exponential what? 3x dot what? Cos x dx. What do you notice here? In this part, we are still having two different functions in product form. So I'll still go further again and integrate this by what? By parts. Are you there now? So let me call this equation what? Let's say equation 1, for instance. Okay. So we say let I2, let what? I2, right? Be equal to what? Yeah. Integral of what? Exponential what? 3s cos what? S d what? ds. Are you following now? Hope you know why I'm going through this process. Because I cannot evaluate this direct. I have to say apply what again? Integration by parts. So I have to say let our I2 represent the whole of this. Is it making sense? So if I2 represents the whole of this, that means my I officially is what? Is equal to what? Let's go. Sine what? Sine s exponential what? 3s over 3 minus what? 1 over 3 what? I what? I2. Equation what is this? Equation 2. But let's solve this first. Let's solve this. From our I2, what's our I2? Integral of what? Exponential what? 3s dot what? Cos what? S delta x, abi? From here, what is going to be our u, yeah? Our u is what? Cos what? X, abi? If u is cos s, what's our du dx? Du the what? Dx. Du dx will give us what? Minus sine what? Sine x, abi? Okay. That implies that our du is equal to what? Minus sine what? X d what? Dx. Now we have our u. We have our what? Du. What? Let's find our dv. What's our dv, yeah? Thank you. Exponential what? 3x. If I'm to integrate this, what do we have? V, right? What's that v? Exponential 3x over what? 3. Are you following now? Therefore, recall that our I2, what's our I2? Will then give us what? Integral of what? Integral of what? Okay, let's say uv, right? Minus what? Integral of what? V du. Are you aware, somebody? Are you following me? This I2 represents what? Integral of u dv. Isn't it so? Which is equal to this. Now let's solve. Then I2 becomes what, yeah? What's that u? Let's go. Cos s, abi? Cos s dot. What's that v? Exponential what? 3s over what? 3, let's put the sign first. Minus. Integral of what? What's that v? Exponential what? 3s over what? 3 times. What's that du? Minus what? Sine what? S d what? Dx. So this will give us what? I2 equals to what? Cos x exponential what? 3s over what? 3. Minus times minus is what? Plus, right? Plus integral of what? Okay, 1 over 3, right? Plus 1 over 3. Are you following somebody? Integral of what? Exponential what? 3x sine what? Sine x d what? Dx. Not the same. Now watch now. This equation what? Equation what is this? 3, abi? So let's put back this. Don't forget that it's from here we have our I2. And this I2 represents this, right? So I will substitute the whole of this into equation what? 2. Are you following somebody? Okay. So I will say put equation what? 3 into equation what? 2. 2 says what? I equals to what? Let's go. Give me the value again. Sine what? Sine x exponential what? 3x over 3 minus 1 over 3 I what? I2. Is it not so? Our I2 is what? Is this. So let's put the value of I2 there. Let's go. So I is equal to what? Sine what? X exponential what? 3x over what? 3 minus 1 over 3 in bracket now. What's our I2? Can I clean this page? Okay. So our I2 is what? Let's go. Cos what? Cos x exponential what? 3x over what? 3, right? Plus what? 1 over 3 integral of what? Of exponential what? 3x 3x sine what? X the what? The x. Are you following? Are you following? Hello, student. Are you following? Okay. Can we expand this out? This will give us what? Let's go. I equals to what? Sine x exponential what? 3x over what? 3. Can we multiply this out? What do you have here? Minus what is it? Cos x exponential what? 3x over what? 9, right? This time this will give us what again? Minus what? 1 over 9, isn't it? Integral of what? Exponential what? 3x, sine what? Sine x the what? The x. Don't forget that we say that our I is what? Integral of what? Exponential x sine what? X dx. Is it not so? That means I can replace the whole of this with what? Somebody. With I. Is it clear? Is it clear? Okay. So we say that recall that integral of exponential 3x sine x dx equals to what? I. Okay? Which is this integral here. Are you there, somebody? So can I replace this here? That means that I will replace the whole of this with what? With what? With I. So that means our I is equals to, let's go, sine what is there? Sine x exponential what? 3x over what? 3, minus cos x, exponential what? 3x over 9, minus 1 over 9 I, right? Good. So the next is to collect like terms, Abi. This and this are like terms. So I'll move this to the other side. You know also? Let's go. What do you have there? I plus what? I over what? 9. This is same as I over 9. Is it also? Are you aware? Okay. So we can say I plus I over what? 9 is equals to what? Sine what? Sine x exponential what? 3x over what? 3 minus what? Cos x exponential what? 3x over what? 9. Are you there, somebody? What's the same between these two? 9. 9 into 1 is what? 9. 9 times 1 is what? 9i. Are you there, somebody? 9 into 9 is what? 1 times I. So plus what is this? I. All equals to what? Sine what? Sine x exponential what? 3x over what? 3 minus cos x exponential what? 3x over what? 9. 9i plus I is what? 10i over what? 9. Right? Are you following? Okay. Equals to what? Between these, what's the LCM here? Hope you know it's 9. Is it 9? Hope you know it's 9. 9 into 3 is what? Divide 9 by 3, what do you have? 3. 3 times sine s es is what? 3 sine x exponential what? 3x. What will be here? Minus. 9 into 9 is what? 1. Times is what you have? We have cos what? X exponential what? 3x. Are you following somebody? Can this 9 go with this 9 from here? You know it's allowed. This can cancel this. I've said before, look at how they're looking at me. If I have this in mathematics, if I have x over 4 equals to x over what? Y. X can cancel s. What's the y? 4. Even if I have this, let's say x over 4 equals to 4 over, let's say over y, yeah? Equals to 4 over y. Y can cancel y. It means x equals over 4. So since there's an equal sign here, and we have 9, and we have 9, you see also, they can cancel out now. Or we can do what? Cross multiply. That's the wrong process. Or multiply both sides by what? By 9. Thank you. Are you there, somebody? I can multiply 2 by 9, or just cancel out your 9 from here. What is the meaning here? 10i, is it not? Equals to what? 3 sine what? 3 sine x, Abi? Exponential what? 3x minus cos x exponential what? 3x. Is that the final answer? No. What the final answer here? Divide both sides by 10, Abi? Okay, when we do that, what do we have? Our answer becomes what? I equals to what? 3 sine what? X exponential what? 3x minus cos x exponential what? 3x divided by what? By 10. Final what? Answer. Final answer. Then plus your C. You can add your C plus C. You can stop here. Or you can factorize, bring out your what? Exponential 3x. But stop here. This is also good as a final answer. Alright, the next example we have here is that if we are giving I equals to integral of ln x dx, you can pause the video and try it out yourself. But let's look at this example. I equals to integral of ln x dx. If you look at it, we have just a single function, ln x. There's no direct integration for ln x. We only have direct differentiation for what? Ln x, right? Which is what? 1 over x. We say that if we should differentiate ln x, the answer is what? 1 over x. So if we are given this to integrate, what we do is that we have to still use integration by parts to solve this. But in this case, we are going to look at a case whereby we're going to represent our du, our u rather. We represent our u with what? Ln what? Ln x. Are you there? If our u is ln x, that means our dv is equal to what? 1. This is like saying 1 ln x. So the first is to say let u equal to what? Ln x. Therefore, our dv equals to 1. Although we don't have priority order for what? For a number, right? But one thing is that once we can be able to identify our u, any other thing becomes what? Your dv. So if your u is ln x, that means the other thing here is what? Is 1, which is what? Dv. Now we know that our u is ln x. Let's find our du, the what? Dx. That will give us what? 1 over what? X. If we differentiate ln x, the answer is what? 1 over x. So that means here, our du becomes what? 1 over x dot what? Dx. Which is same as dx over what? Over x. Okay, now we have our u, we have our du. Our dv is equals to 1 from here. If u is ln x, our dv becomes what? 1. Now to solve for v, we have to integrate this v. So to integrate the v, our answer is v, and the answer is what? Is x. When you integrate 1 is x. When you differentiate x is 1. So the reverse of this is still what? Is still x. Now we have the v, we have our v. Recall that integral for u dv equals uv minus integral of what? V d what? Du. Formula for integration by what? By parts. So applying the formula simply means that we are going to have our integral of u dv, which is also same as our I, right? Is equals to what? What's our u? Our u is what? Ln x, right? Ln x dot, what's our v? V is what? X. So that will give us x ln what? S, right? Are you aware? Okay. Minus integral of what? V is what? X again, dot. What's that du? The X over what? Over X. Yeah, X can go with what? X, right? So we are left with what? I equals to what? X ln what? X minus integral of what? Of the X. Integral of the X. What do you say, man? Integral of 1 dx. Right? So by the time we integrate 1 dx, what do you have again? What do you have there? That should be X, right? So we're going to have X ln X minus what? X plus what? Plus C. Between these two terms, what is common is X. So I becomes what? X in brackets ln X minus what? 1 plus what? Plus C. Final answer to this. So anytime you see integral of ln X dx, what's the answer? Is X ln X minus X plus C, or X ln X minus 1 plus what? Plus C. Are you getting the gist here? So put this out.